Welcome to the workshop on creating resilient, sustainable microgrids. We have more than 200 participants registered, which demonstrates the high level of interest in the rapidly developing field of microgrid design, planning, and implementation. Microgrids are nothing new, but recent technological advances in small-scale renewable power generation and smart grid design make them a cost-effective solution, particularly for places where large-scale transmission either does not reach or fails to give a reliable supply. Universal access to affordable, modern, clean energy is Goal 7 of the UN's Sustainable Development Goals. The SDGs state that energy is central to nearly every major challenge and opportunity the world faces today, be it for jobs, security, climate change, food production, or increasing incomes. Access to energy for all is essential. In sub-Saharan Africa, more than 625 million people have no access to modern energy services. Most African countries, 42 in all, are net energy importers, and fossil fuel-fired plants account for 81% of total electricity generation, which is mostly in South Africa. Most large infrastructure projects are public investments financed by national budgets. The estimated cost of bringing Africa's energy infrastructure to modern standards is $93 billion US dollars a year. There's a huge gap between energy supply and demand in Africa and other developing countries that successive efforts have failed to bridge. The envisaged holistic hybrid microgrids will lead to a prototype model for the creation of sustainable and resilient distribution networks for off-grid locations, with the potential to enable the electrification of millions of households. Typically, the electricity distribution system planning and real-time system operation are considered as two separate stages in the overall grid design. First, information such as consumer load profiles and growth, land developments, available generation units, the regulatory framework and weather conditions are used in the planning phase to design the distribution grid for the worst case scenario. In a second phase, the real-time operational strategies are designed to optimize the grid operation and reduce the operational cost. This approach is appropriate for regions with a developed, strong electrical distribution infrastructure, standardized ancillary services, and market-based energy trading mechanisms. However, it may result in prohibitive high costs and suboptimal energy system design and operation in developing countries with weak or no electrical infrastructure, because the requirements of remote rural communities in terms of demand, flexibility, power quality, reliability, robustness, maintainability, cost, resource access, and local acceptance differ substantially from those in developed countries. In addition, the lack of existing electrical infrastructure diminishes the available data required for the planning phase, such as load consumption patterns and types of generators and costs, and so on. Finally, the existing pool of energy generation units is restricted by the scarcity of resources and the technical expertise of the local communities. Therefore, a power system design in developing countries enabling self-sustained and resilient energy distribution should ideally take a holistic system approach, integrating both the planning and real-time operational design into a single joint design stage. Such an approach should explore the socioeconomic and energy resource dimensions to extract energy consumption and generation relevant data and incorporate them through appropriate cost factors and constraints in the overall optimization-based design procedure. This workshop is part of a 3-year project on creating resilient, sustainable microgrids, and it's funded by the UK Engineering and Physical Science Research Council through the Global Challenges Research Fund. The project is composed of 3 work packages. The first on planning and design of flexible and robust microgrids. The second on tailoring the microgrids to community needs. And the third on sustainable and resilient energy generation. Today's workshop is from the first work package and is focused around 3 themes. Firstly, towards resilience, flexibility and sustainability in remote microgrids. Secondly, towards planning of sustainable microgrids. And thirdly, operation of sustainable microgrids. We're very pleased to host some excellent speakers from both the project team and international experts. And I will now hand over to Professor Kang Lee to chair the first session.
And